Hello, I would like to demonstrate Cimatron's automation ability for our NC machining. Let's begin by opening up a NC file, which would be some inserts on a bar. I'm going to choose the start file. Okay, and the idea here is that this geometry maybe came in from a different system. We're going to assume that there aren't design standards in place, and then we'll talk about how it could be different if there were design standards in place. So assuming that this is just regular old geometry imported from a different system, there's a little bit of preparation that we're going to do up front. First thing that I'm going to do is switch to the CAD side, and we're going to go to the sets page, and again, for purpose of demonstration, this will be a little bit different than reality. So I'm going to choose load sets, and I'm going to go to a file that contains a set or a level structure that my NC templates are going to be driven by. So I go to this, let's call it a master sets file, and I'm going to bring in these sets. Okay, and so I've got a set called base, engraving, engraving face, part, platform, sharp edges, and Z-stop. So I'm going to go through here and satisfy each set. So for the base, I'm going to edit this and go to the front view. And I'm going to pick these surfaces here. And for the engraving, I'm going to pick this stuff. For the engraving face, I'm going to pick this one. For the part, I'm going to pick this. For the platform, it's this stuff. And for sharp edges, I need to draw a composite curve. Alright, and again, for sake of demonstration, I want to show some more functionality. I'm going to click on New Set by Criteria, and I'm going to go up to the color dropper, and I'm going to set my color to be this salmon color, and then here I set it to be current. And let's do one more color, which will be the gray. And let's call this our area. Okay, so the point that I did this for is that I can turn off all entities. I can turn on just this part area. And now I'm going to go to the composite curve, and I'm going to choose faces outer boundary. So I can just box pick each of these and get a nice composite curve around everything quickly and easily. I'm going to go back in the display, and then we're going to put those composite curves on this set called sharp edges. So I'm protecting these edges to not be rolled over with the cutters. Okay, and then the last thing is a Z-stop. Now this is pretty optional. I would say that normally we probably wouldn't need this, but when the shape of the, we're going to cut from two sides. We're going to cut from this side We're going to roll it over and cut from this side. So from this side, I want the cutters to come a certain distance past. So while we can limit the Z with values and whatnot, for as quick and easy as this is, I think it's a fairly good idea. I'm going to go into the sketcher. I'm going to pick on this face. I'm going to use a arc tool, and I'm just going to put a little radius there like that, and then sweep. Okay, and then this is my Z stop surface. Okay, so I think everything is ready in order to add the template. So we're going to go to the NC side, and we're going to choose Apply Template. Actually, before we do that, we want to make sure what UCS is active, because the UCS that's active is going to get attached to the incoming template. So setup number 1 is going to be the back side, and I'm going to choose Apply Template, and I've got let's see, it's not the right spot. Okay, here it is. So I'm going to take the backside template. Alright, and this is all being driven by criteria. So first thing is the height of the clearance plane. And then the target part. That's what it's supposed to look like when it comes off the machine. The stock. Now the stock is a bounding box of the part level and the platform level, but I need a little bit more. So I can come up here and pick this chain in order to include that in the bounding box data, and now the stock model is good. And my stock model is not coming below this area because I don't want to machine this base area, so it's important that the stock model stops right there. Alright, now we go to the well, basically we can just launch these. So I'm going to go ahead and select these and choose execute. And while those are calculating, we're going to add another template. But we need to change the UCS. Now we're going to do the front side. So now we're basically looking at it like this. And we apply template. And this will be the inserts on bar front side. Okay, and you can see that it's using the appropriate coordinate system. And there shouldn't be anything to do here. Again, it's all going to be driven by sets. So I think we can just go ahead and calculate it. I'll stop the video here, and then we'll restart the video when there's some results to review. Well, actually, I have results to review. Sorry. Let me open up a different file. We will look at the finished. Okay, so here's the first rougher. Comes in with a 1-inch cutter and roughs all that away. It's being limited by this Z stop face that we put there, and I'm using 2 part surface groups. So part surface group number 2 is the little Z stop face, and I put a formula there that says you can violate that Z stop face by the corner radius. So whatever the corner radius is of the tool, it can poke past that in order to go a little bit deeper down in the roughing. I have a 62 thousandths corner radius on my cutter, and so the violation is 62 thousandths, just to help it get a little deeper in the Z. Okay, then we have a 1/2-inch cutter coming in and picking out the corners. That's just a roughing remachine. Does a nice job. Then we have a 1/4-inch cutter. It's cutting a little bit more than I'd like to see up here, and we could do something about that. But for a quick template, it's not a bad result. Alright, then we have the 3/8 ball cutter coming in and doing the finish machining. And let's have a look at that. So here we have the part area is selected for the part surfaces. The base and the platform is selected as a check surface so that we don't machine any of that stuff. And the horizontal areas are being cut with a parallel cut with the automatic angle along the longest direction. And then the vertical areas are being cut with a Z layer. And what's nice here is that the tool doesn't waterfall. So whenever the tool no longer is contacting the surface and it's going to waterfall down that edge, it just stops right there, because there's no point in machining that when you're not really machining it, you're not finishing it. So automatically the tool is capable of giving us that result, which is very nice. So we finished from this side all that can be finished without having to give it any limits, Z limits, or anything like that. And now the other side, we're doing roughing, and I want to point out that from this side, I'm not using that Z stop face. That face is not selected, and it knows what material was removed, and it's only machining as deep as the material actually is there. And we can look at that by turning on the stock model here. Change the color of this. Okay, so here you can see the stock model, and you can see that it's not machining any deeper than what the stock model is. Alright, then we have a 1/2-inch remachine with basically a semi-rough. Then we have this would be a horizontal floor procedure, but there really aren't any flat floors, so that's probably not a worthwhile program to run. Here we have another rougher with a 1/4-inch bowl. This would be horizontal planes again, but I probably would just delete that. There's not a need for it. Then here we have the remachine with an 1/8 inch cutter. And now we're getting into the finishing from this side, and here's where I protected the edges. I can say keep these internal sharp edges protected, and that is looking at a set. If we look at the criteria, it says look at the set, it's called sharp edges, and it's going to automatically protect all these edges so that we don't round off any of those corners and allow the plastic to flash. And it behaves a little bit differently. Here, where the motions are Z layer, it's arcing on and off and not rolling around that edge. But in the horizontal motions, where we're doing a parallel cut, it's going to lift up ever so slightly to avoid, right here we can see it, we go to the navigator. You can see it lift up right here. To protect that edge. And you'll see it here too. Very nice. And again, we're not waterfalling past any of these areas. Once the tool is no longer making contact with the surface from that direction, it just stops machining. So I don't need to give it a bunch of bases and Z limits, or becomes very automatic at that point. Okay, so from there, really it's just remachine cleanups, and we're going to a 1/4 inch cutter, a 1/8 cutter, a 1/16 cutter, and a 1/32 cutter. This is all very quick and easy. The engraving is also automatic in that we told it what set the engraving was on, and we gave it the surface to project against in the set. Let's change that color to red. And a little wireframe. Okay, so here's the engraving. All done automatically, driven by sets. And then lastly, on the top, this is of course assuming that you have a 5-axis machine, but what I did on the top is I wanted to drag a flat cutter along this face, and I wanted to position the tool 90 degrees to this edge and pick out along this edge. But you can see there's a little bit of an angle change here. This is like a partial radius or something where it kind of tips back on itself. So when I set up the procedure, I told Cimatron that I wanted the cutter to be 90 degrees against the cutting edge, which is this green surface, but I'm checking against this yellow surface. Here on the gouge check page, you can see that this one is going to tilt the tool away in order to not violate this yellow surface, and I could say, you know, stay away by 1 thou, 2 thou, whatever I want to do. So that's one condition that I have for protecting a surface. The other one is this one, where I'm asking it to retract the tool along the tool's axis and protect these surfaces. So the tool is going to run along here, it's going to lift up to avoid cutting or violating this little change in level. So it's a pretty complicated procedure for what I'm asking it to do, and it really worked out nice. Let's have a look at the result. Go to the navigator. Okay, so the tool comes in. It's going to lay back against this wall, checking against this top edge, and it's trying to pick this out. And it's going to lift up before it runs into that surface. Very nice. This is the kind of tool control that you can have with Cimatron. Pretty much if you can imagine it, you can make it happen. Absolutely perfect. There aren't many systems that have this capability. This is really awesome. I could also come back and I could drag it along this edge with the flat of the tool, parallel to this floor, and that would be no problem either. So 2 passes across here and you get that picked out instead of 50 passes across there. Alright, that's it. And as I was saying earlier in the beginning of the program, that if you are using Cimatron for design and you have the luxury of having design standards, the designer, or whoever is building these inserts on a bar, could already have these sets set up for you, or it could be a color thing. The platforms could always be yellow, the base could always be purple, and then the part could be any color, and you can say the part is any color except purple and yellow, and you're guaranteed to pick it up. So there's a lot of easy ways to implement design standards to where you don't have to even put this stuff on levels. The design standards allow the templates to work right out of the box, and there's literally no work to setting it up. You just bring in the file, apply the template, everything is set up and ready to go, and you'll have to do a little bit of editing and tweaking to finalize it, but this really is going to dramatically speed up programming time. Thanks for watching.